All right, in this video we're going to talk about glaciers, we're going to talk about wind, and we're going to talk about waves. All right. So we have a couple different types of glaciers. One is called a mountain or a valley or an alpine glacier. These are the smaller glaciers that form at higher elevations in the mountains. So the Alps, the Rockies, the Himalayas, the Andes. All right. What differentiates the erosion, the weathering and erosion of glacial valleys from river valleys, if you remember we talked about river valleys are V-shaped. Well, glacial valleys tend to be more U-shaped. Right? They carve out a large chunk at a time. Right? They actually move very similar to water, running water. The center also moves faster in a glacier. The overall glacier obviously is moving very, very, very slowly, but it's similar to running water in the sense that the center of the glacier does move faster than the edges, and that's also because of friction. All right. Now here's a little cross section of a glacier. If we look, notice where the fastest portion is, those longer arrows. It's near the surface and in the center, just like in water. Okay, near the center and side view here up toward the surface, not right on the surface, but a little bit below, just like water. Right, still got friction. All right, still got friction everywhere. Here's a little cross section of what they look like. Down at the bottom of the glacier, we have the very, very well compacted snow that turns into ice. This is the solid ice at the bottom of the glacier. All right, as we move up, we run into a layer of what's called firn, F-I-R-N. Firn is kind of an in-between phase between snow and ice. And above the firn is snowpack. Right? This is like the previous year's snowfall. Right? And then up on tip top is you've got the current snow that's already fallen on top of it. So over time, this, just like other things, it gets compacted. And if you've ever taken like a handful of really, really, really wet snow and squeezed it between your hands to make a snowball, you can turn it into an ice ball. Right? This is the same principle. The snow is getting compacted over all the weight from all the weight above, and at the very bottom of the glacier, it turns into solid ice. All right. As this glacier is moving downhill, just like water, it picks up and moves rock material. Does it a little differently, all right? But the stuff that it carries, unlike water that sorts material by size, biggest to smallest, glaciers do not sort material. They carry it all as a big jumbled mass of material, small sizes, big sizes, everything. And that material that gets carried by the glacier is called a moraine. Okay? And there are different types of moraine depending on where it is. The stuff that's carried along the edge of the glacier is called the lateral moraine. The stuff that's down at the end down here is called the terminal moraine. And if you have a couple of glaciers coming together, the two laterals up here will form a medial or a middle moraine. Right? It doesn't matter. You don't really need to know the different types of moraines. Just know that it's the unsorted material that's carried by a glacier. It doesn't separate out the sizes. It just carries it all as a big jumbled mass, big pieces, small pieces, middle, that whole thing. All right, don't need to worry about that right now. All right, so here's kind of a couple of pictures to kind of demonstrate the difference between the V-shaped valley and the U-shaped valley. All right, remember the V-shaped valley is what we get from a stream. The U-shaped valley is what we get from a glacier. That's a major concept that they're gonna ask you about. All right, V-shaped stream, U-shaped glacier. All right, the second type, so we've got that mountain glacier. The second type is what's called a continental glacier. The reason it's called a continental glacier is because it covers large land masses, continents, more than continents, but large land masses. We sometimes call those continental glaciers ice sheets. Two major ice sheets that we have are Greenland and Antarctica. All right, there's a lot of ice there, a lot of water trapped up in that. Okay. All right, this little diagram here, this little picture shows the extent of glaciers during the last ice age. You can see it went all the way down into the United States, almost down into Alabama, Missouri, Mississippi, those areas. Okay, basically the whole north, for the most part, was covered with ice during that time. Right, we have evidence of at least 4 major ice ages over the last 2 million years. Right? In between those ice ages, we call them interglacial periods. We're in an interglacial period right now. Okay, our last ice age ended about 10,000 years ago. All right, yes, there were people, yes, they survived it. All right, 10,000 years ago was the end of the last ice age. Okay, they call it the Pleistocene ice age. So right now we're in a generally a warming trend. All right, the planet is generally getting warmer. We're interglacial, between glacial periods. All right, this little picture shows, if you look at, we got Boston, Massachusetts, we got Cape Cod here, Nantucket, Martha's Vineyard, Long Island from New York. Right, all these things right here, these were never here initially. These weren't originally part of the North American continent. Right? These were formed when glaciers moved out of Canada. They bulldozed their way south, pushing material, and they stopped right here. Right? And once the once the climate started to warm up and the ice melted, it dumped all that sediment right in this area. So these things are actually what's called glacial till. It's material that was deposited out in the ocean there, and it deposited so much of it that it formed some islands here, formed a little peninsula here. But these were not originally connected. These were not originally part of the North American continent. They were added here during the last ice age, 10,000 years ago. All right, so this is all add-on right here. Niagara Falls, okay? Big impact of glaciers. One of the big impact of glaciers is carving into the rock. And the falls were created when the last ice age ended and the ice receded, melted away, and all that water started to melt and rush down through those valleys and over Niagara Falls. Right? That started from glacial meltwater, carving glaciers, carving those valleys, those river valleys, and then when they melted, all that water rushed down through there. Right? So you may have heard of the American Falls, right? The side that's on the American side. You probably heard of the Horseshoe Falls. Some people call them the Canadian Falls on the Canadian side. And then there's actually one more that not a lot of people, I didn't put it in here, but not a lot of people realize that one right there, that's actually got its own name. It's called the Bridal Veil Falls. You don't need to worry about that, but the point is these were created during the last ice age. Okay? Here's the Great Lakes. We got Superior right here, Michigan, Huron, Erie, and Ontario. So the water from Michigan flows here, or excuse me, water from Superior flows here, Michigan here. Then this water flows here. This is a St. Clair Lake right there, that mini Great Lake. Goes into Lake Erie right here. And then right here, this is the Niagara River, and there's Niagara Falls right there. So this water actually flows north over the falls into Lake Ontario, and then it goes out through the St. Lawrence River to the Atlantic Ocean. Finger Lakes here in New York. Right? Obviously why they call them Finger Lakes, right? But they were created by the last ice age. Glaciers moving south out of Canada, came down through from the north like this, and they carved out these giant caverns in the softer rock that wasn't as resistant. And then as the ice receded and melted away, they filled with water. And that's how we got the Finger Lakes. Right? You can see the little inset of it down here in the bottom corner once this little bar disappears. You can see the little yellow inset area. That's where the Finger Lakes are. I like this little picture here. This kind of shows the coastline of the United States. This black line right here is where the coastline currently is. Here is where the coastline was 18,000 years ago. 18,000 years ago, the oceans weren't as high. And so the coastline was here. And then as the water rose, now this is our new coastline here. And they predict if all the ice sheets, if Antarctica and Greenland all melted, this would become our new coastline with some islands here that are at higher elevation. This would become the new coastline. So basically Memphis, Tennessee would be underwater. It would go all the way north up into Kentucky and all the way back down. So, Florida's gone, New York City's gone, Houston, Texas, those areas would all be gone. If the water rose that high, if the ice all melted, that's going to become eventually the new coastline of the United States. All right, wind. Okay, so we've had running water as an agent of erosion. We've had glaciers as an agent of erosion. Now we've got wind. All right, wind is another one. All right. Usually we get a lot more wind erosion in dry climates and along shorelines because you've got breezes coming off the ocean, things like that. All right. All right. If you look at this picture here, we've got a rock out in the middle of this desert area. The wind carrying all the sediments is going to pummel this rock right here, and over time it will slowly wear it down. You can see where it's worn down the most on the windward side, and it kind of doesn't wear down as much over here on the leeward. This wind-worn rock is called a venifact. Right? You can see them all over the place. Okay. All right. So wind, just like water, sorts sediment. Now, wind can't carry as big a sediment as water can, but it still sorts them. All right. And the amount of sorting, what we're talking about is the range in sizes. If you have a well-sorted group of particles, that means they're all pretty much the same size. Right? Generally speaking, when you see well-sorted sediments, you know we're talking about either wind erosion, or we haven't talked about waves yet, but wave erosion and running water. Those three agents, running water, wind, and waves, tend to...
Pardon me.
All right, and down in the bottom picture, we have poorly sorted sediment. Whenever you have poorly sorted sediment, notice you have a mix of particle sizes. We're generally going to get this mostly with just glaciers, all right? Glaciers just carry everything as a bulk quantity. They don't sort it. When the ice melts, it just dumps the sediment wherever it was, and it doesn't sort it out by size. Wind, waves, running water, those sort the sediment. Glacial action, glaciers do not sort sediment, nor does gravity by itself. If you got a cliff face and a bunch of particles just break off the cliff face and fall to the bottom, they're just going to be a big jumbled mix of different sizes. It's not going to sort sizes really well either. Now, they are going to get a little bit, but it's not going to sort them like these guys are. All right. All right, and then finally we have a little picture of a sand dune here. All right. Anytime you see a sand dune deposited by wind, you can tell which way the wind is moving by the shape of the sand dune. All right. Generally speaking, the gentle gradient side of the sand dune is the side that the wind is coming from. So it blows up the side like this, carrying sediment, and then as it crests over the top, it dumps its sediment on what's called the slip face, or the leeward side. So in a sand dune, you can always tell the direction the wind is blowing. The gentle slope side is the windward side. The steeper slope is the leeward side. Okay. There's our well-sorted sediments. Those sediments that are deposited by wind are called less. Okay? Less, pronounced less. The O is kind of silent. Right? All right, here's just a picture showing, you can see how the wind's going up and then down, up that way, down that way, up and then down. It creates different sand dunes. All right. You can actually see it in this rock, how these were wind-blown sediments at different directions based on, you can tell which way the wind was blowing based on how the angle of the rocks are, where the sediments are in the rock. All right, and then our last agent of erosion are waves, okay, wave erosion, okay, shorelines, all right? just like running water, waves can change the shape of the sediments too. It can make them smaller, make them rounder. Okay? As these waves are coming in, the water breaks on the shoreline. It grabs the water and drags it back out, bangs it on, drags it back out. Okay, so they serve to erode the shoreline also. They use what's called wave impact. Right? As the wave hits, it breaks down the rock and then it drags it back out to sea and moves it. Hits and breaks, drags it, deposits some, pulls some out, deposits some, pulls some out, does it over and over again every time a wave breaks. All right, sand is generally carried along the shore. All right, it's called the longshore current. If you see this picture here, it looks like the wave is coming in this way like this. So the sediment gets deposited, and then as the wave breaks back out, it pulls sediment this way. And then it deposits some here and pulls it this way, and deposits some here and pulls it this way. And the overall effect is the sediment gets dragged this way along the shoreline, and it builds up this way. Okay? I just want to throw this picture in here. You hear people talking about rip currents, or sometimes you might have heard them called rip tides. Okay, they have nothing to do with the tides. Rip current is just water that's flowing back out to sea. And you can see how it breaks up the normal flow of the wave coming in. All right, so some effects of wave impact. Okay, abrasion. As that water breaks on the coast, it's carrying sediments, so those sediments bang against other sediments and they serve to round them and smooth them off over time. They rub against each other, that kind of thing. Right. Some features made by sand being moved by the waves. Okay. Ridges of sand, maybe underwater, maybe above the water. Those are called sandbars. You may have heard of some of those. Okay. Little islands that run parallel to the shore. Those are called barrier islands because they kind of block the waves coming in. This right here would like protect the coastline a little bit. If we got a little peninsula of sand jutting out from the main coastline, that's called a spit. All right, a spit of sand. And we have a few structures that humans build. We humans, we got to get involved in everything. All right, we want to control some of the erosion that goes on coastlines, for tourist attraction, things like that. Okay, so we create things like breakwaters and jetties. They're little structures that we build in order to block some of the waves. And if we can block and cut some of the waves down a little bit, they don't have as big an effect on the shoreline that you're working with. Right. So if you see here in this bottom picture, the waves are coming in from this angle right here, and they're cutting in the shoreline here. But it's not moving very much here, so the stuff gets deposited over here. And that's what happens in this picture over here. You can see the waves coming in from the top left. So what happens over time is you'll get a buildup of sediment on the wave side, and it'll cut in on the other side. Right, where there's no, it'll cut in, it'll erode. All right, so it carries that sediment in, so it'll change the shape of the shoreline over time. Right? And periodically, they might have to dredge it out, clean it out, that kind of thing. You see this down in Sylvan Beach. They have those little jetties that go out from where I think it's the Fish Creek, comes into the lake.